Hey everyone, I'm going to be showing you how to set up the software development environment for deploying the Rasa app across multiple Docker containers. And I have this guide that's from my GitHub repo that we'll be going through, and it covers multiple steps. Also, if you're interested, I have the demo videos for interacting with the Rasa Chatbot from Rasa Shell, from Slack, and from Unity. Today's demo, we'll be going through how to set up the software development environment specifically for running Rasa Shell or running Rasa, interacting with Rasa from Slack. Some on chatbot functionalities, deliverables, some information on the software development environment. It includes Rasa, the Rasa SDK, Scrappy Web Crawler, Java Spring Boot, MySQL, and Ngrok. Multiple Docker containers that'll be running that software. So for you, you would clone the GitHub repo, and then you navigate to the path, the folder. First, we're going to follow this link here, which will take us to deploying MySQL, Spring Boot, Docker containers. And so what we have Docker desktop. This is one way to see the Docker images that are currently here. Currently, we only have one that we're not using for this demo. So we're doing a fresh start. And so to do that, first we'll check if those networks have been created. So we'll do a Docker network list. Okay, so the Rasa backend and the Colon Cancer Mayo Clinic. So we have created those, but if you didn't have those, you could run these commands to create them. And then we're going to deploy Docker containers MySQL server in the background. So in this case, we'll do a Docker pool MySQL 8027. And we will cd to GI Cancer's MySQL DB, but for the Docker pool, we don't need to do that yet. So right now, Docker is pulling the latest, that particular image from Docker Hub. Okay, and what we see is we downloaded the image. We can see that MySQL is in fact in the Docker desktop GUI. Now we'll cd to our GI Cancers. So mine is in documents, it's in a folder called GitHub, and then GI Cancers to the gallery. Go into GI Cancers, MySQL, DB. What's in there is a Docker file for creating the specific Docker image. So reason we got MySQL 8027 is because this Docker image that we're about to build for MySQL is going to take that and then build on top of it. And what you'll notice is there's a schema SQL in there, and just a bit on the contents of that Docker file. So this Docker file, what it does is it copies over that schema SQL to this folder to initialize our Docker image environment. It will, off the bat, when we later deploy a Docker container from this Docker image, it's going to create the database and the tables that will be used in Rasa Chatbot. There's just one table will be actually populating with data, but later I show that in another demo video. And that's the patient symptoms table. So going back to the guide here, what we'll do is we'll do a Docker build GI Cancers MySQL DB dev. So this is going to build that Docker image. So we see now GI Cancers MySQL DB has been created. this command here is going to create a Docker container from that Docker image and setting some arguments for the Docker container. Restart always is something specific to MySQL. Running on port 33.7 and 33.6 is something also specific to MySQL. Typically on the internal side, MySQL will run on the 33.06. On the host side, it's 33.7. And then we're going to connect this Docker container to the Rasa backend, and we're deploying this Docker container from our Docker image we just created. So just did Docker run d name Rasa GI cancers db restart always. That is the port network equals Rasa backend GI cancers MySQL db dev. So now what we can do, we can look at the Docker desktop. We can see that our Rasa GI cancers database is running. And let's jump into it. So we can do a Docker exec it Rasa GI cancers db, and we'll do bash. We're inside the Docker container. We'll do MySQL u Rasa docker -p. Password is just Rasa docker, and we're inside the MySQL prompt. What we can do is we can do show databases. So this is what I was talking about. We have GI cancers database. We'll use that. And now what we can do is we can do show tables. And so these are the different tables for the project. I later in another demo with interacting with Rasa Chatbot through Shell or through Slack, Rasa will be collecting data on the patient. Again, that's just the patient's symptoms for colon cancer, and that'll be populating the PCC symptoms table. To expand on the application, though, we could collect data on the patient, the doctor, etc., and store them into these other tables. So we'll quit for now. And next, we're going to deploy the MySQL, the other Docker container, which is Spring Boot, and that'll be communicating with MySQL as well as the Rasa Chatbot. So we can exit from the MySQL Docker container. And then in this case, we can install OpenJDK and Maven on our conda prompt. So let's do a conda install -c conda forge. This is OpenJDK. We're doing it directly in the base of our conda environment. So this will get installed. We'll say yes. And OpenJDK 11 is the version that we're using for Spring Boot for this particular app. But to run Spring Boot, we could also use a newer version of OpenJDK as well. So we just installed OpenJDK 11 with conda. Next, we'll install Maven. All right, Maven is installed. So we'll take a back to the previous directory, and then we'll go to GI Cancers API. And in this case, what we can do, we can run Maven install. So this is just building the app. I think it has to do with a issue related to Maven. Let me see the version that I have, or not that one, this one. Let's try that. WCMD install. I think I remember how I did it. So I think what I did was I opened Ubuntu on Windows. So not Conda. And then for this, instead of using these, I did apt-get install OpenJDK headless and Maven. So let me go do that. Yeah, we're gonna make an update to that real quick. So I'm gonna go here. I'm going to say open WSL Ubuntu terminal. Install those two. Apt update. So I think that was the major difference. This will be fine running it. 17 JRE headless. It'll do similar. Even okay. Open WSL Ubuntu terminal. Install OpenJDK and Maven using I would just say recommended use Ubuntu WSL VM or server for this part. So what we'll do a quick update. Your password, whatever that might be. Okay, now that is already installed. So is Maven. Okay, and so what we'll do is we will cd to GI Cancer's gallery, documents, GitHub, GI Cancers 2D gallery, API, and now we'll run Maven install. It might fail because I already ran it on Conda. So I might have to delete that target directory, maybe not. Okay, build was successful in Ubuntu WSL. Build failed in Conda. Most likely it had to do with probably we didn't have OpenJDK 17, which I'll verify later. Okay, so that worked. Now what we can do is we can build our Docker container. If we look at WSL as well, we'll see that we have access to our Docker images as well. That is just because in the backside here for Docker, meant this gear, what it uses on the back end is WSL, and that's typically by default on Windows. Okay, so we're just going to build Docker GI Cancers API. This is that Docker image. Okay, so we should have that new Docker image. What we'll do, we'll run this Docker run in our Ubuntu WSL as well, because it'll just be an easy copy and paste versus command prompt. I had to type it in manually, and that was just mainly because of these forward slashes. It's slightly different for the command prompt, but forward slashes is the way that we carry on to the next line and then to the next line and so forth. So what we have is we have our Rasa Spring Boot server that's running now on port 8080, and it has a connection to the database through using Rasa GI Cancers, that Docker container name, on port 3306, specifically to the GI Cancers database. And then what we also do is we have our Spring Boot Docker container connect to the Colon Cancer Mayo Clinic network. So I'm just gonna copy that over. So now our Spring Boot Docker container does that. And one thing we can do is we can just monitor the application log. So we can see here, Spring Boot started, things look fine. And so that's MySQL and Spring Boot. Okay, and then next is we're going to do the Rasa part now. So coming back to the command prompt here, because again, we used Ubuntu WSL for building the Spring Boot part. We're going to use command prompt, and we're going to go to the Rasa Docker file. So that is in Rasa apps, Rasa Docker file, and then we'll just build this new Docker image. So we should see a new image that comes up. All right, so our Docker image just finished building the Rasa and Rasa SDK environment. It also comes with Scrapey as well. So you can see here and Scrapey do. And so now what we're going to do is, we're going to CD to the colon cancer VA. Need to go back one, and then actually that should be fine. So we go back one, we go to colon cancer, and then again, this would be if you don't have the colon cancer Mayo Clinic. So we just went through the steps in the other MySQL and Spring Boot, and I believe we created that colon cancer Mayo Clinic. So you would just check, verify that you do have that network, which we do. So we'll just move to the next one. I'll say here, actually, if you don't have the following Docker network, we will create, and then we're going to deploy Docker container where we'll run Rasa action server. So this looks good. Again, this has to be the absolute path to your colon cancer VA folder. So on your Windows command prompt, your path might be different depending on where you cloned GI Cancer's 2D gallery. Just heads up on that. And then this will launch a Docker container Rasa action server, which we can see in the containers view. There gets created Rasa action server. And so what we'll do is we'll jump into it as well. I misspelled that. Right, and we'll cd to the app folder. We'll run Rasa run actions. So that will run action server. Things go well, we can see all the registered functions and that our Docker container is running on this URL. And we'll open another Anaconda prompt. This will be for talking to our Rasa Chatbot from Shell. I'll briefly go through this one and then we'll focus majority of on connecting our Rasa Chatbot to Slack. So this is just documents, GitHub, GI cancers, 2D gallery, Rasa apps, colon cancer. So just a brief, we can see, those particular files and folders in this directory. And so we're just going to launch this next Docker container, Rasa shell. Again, it has to be the absolute path. That's what we're doing for the volume mount. We're connecting our Rasa shell to the colon cancer Mayo Clinic network so that it can connect to the Rasa action server. Right, we're already inside the Docker container because we did interactive mode, which oh, right. So the reason that we didn't go straight into the Docker container here is because I have the -d argument. So this Docker container runs in the background. And so we had to manually run this execute command. So what I'll say is once the container is launched, you'll be automatically put into it. So you'll automatically auto jump into it. Execute. Yeah, so we're already in it. And so we just go to that app folder and we'll do Rasa shell. This is where it's going to load this model. The model is in this models folder. Yep, we can see that it's going. Loading the model. This model, so is the model that I used during the demo that day for CMPE252. So once we have that, these are some example statements, questions we can use. Okay, so let's just try one. I'm visiting about colon cancer. Do that, and the Rasa chatbot responds with, "What are your queries on colon cancer?" So we'll finish the other statements in Slack. So I'll just do Control C for now to exit that. And then again, we have this Rasa shell. What we'll do, we'll just stop it. That's just to show that Rasa shell is separate from Rasa run server. So now we're going to focus on Slack. So just a few things I want to show. The first thing is in the credentials YAML file, we'll need to update Slack token channel signaling secret. So we have credentials. I updated it with my info. Yours will be different for your Slack app. So that's why I have this browser open as well. So we're going to go to the Slack app, and then we're going to go to basic info. Scrolling down here, we can see there is the client secret. There's the signing secret. So we can show that, and that's our signing secret. The client secret is something different, actually, never mind. And then we are interested in that Slack token. So I believe that Slack token is in the OAuth and permissions. Yeah, so in OAuth and permissions, that's where we get that Slack token. Really, Slack token is bot user oath token. So what I'll do is I'll just put a little comment here for your reference later. Bot user oath token. Yours will be different again. So you'll just copy and replace this with yours. Then the Slack channel. So the Slack channel can be found in our Slack. So I have the Slack desktop version. So you'll just click, let's see, Slack channel. Manage apps. Those are separate. Let me double check where that is found. Rasa Slack. Slack channel. Channel ID, not a channel name, right? And channel individual person that the bot should listen to. In addition, to get the channel ID, right click on the channel in Slack and choose copy link. So I think it's just this, and then quick, we'll put that there. Okay, and so right click on the channel, that was different. This is the channel. Okay, I think this is the copy link that they're referring to. So we can already see that my Slack channel ID has changed for the chatbot. So we'll come back to this part in a moment as we do the test. So let's go back to where we were at a moment ago. Yeah, we were here. So we were about to launch our Rasa run server. So we'll take this command and we'll copy and paste it over. Go straight into the terminal. We'll go into the app folder. We'll do Rasa run. So it's going to start the server. It's going to load the model. And then we'll open one more command prompt after that. So it's showing Rasa server is running. So what we'll do now is we just opened the command prompt, right? This time we don't need to go to the project directory. We can just launch this container right away. So our Rasa run Docker container is called Rasa run. It's running on port 5005, as we can see right there. And so what we're going to launch a Ngrok Docker container, and it's going to interface with the Rasa run server at port 5005 with that HTTP Rasa run 5005. So we'll launch this. And we can see here that the image is not found. So what it's going to do is it's going to do an automatic Docker pull to get that Ngrok Docker image, and then we're going to launch the Docker container. Okay, so our Ngrok Docker container is running. We can see here that it is in fact there, Ngrok integrate Rasa. And what we can do is we can go to this link here, localhost 4040, inspect HTTP, and we can see any requests that come to our Ngrok server. What Ngrok will do is and here are the two URLs that it generates to allow our Rasa app to be exposed to the internet. We're going to give this to Slack API. Just replace these two here, and we'll replace this part here with this first one, because we're just going to go with HTTP. Okay, just like that. So we'll come back to this page in a moment, but what we'll do is open this in another browser as well, tab, and then we're going to go to event, subscriptions, enable. So this changes every time that we launch or start up the Ngrok Docker container. It'll generate a new URL for us, so we have to rerun this. Keep in mind the credentials part for channel ID that might have to be updated. So what we're going to do, we're going to do that. And it's been verified. If we look at Ngrok, we can see here that it received it, right? And it was a 200 for a success. And it looks good on this side. So we'll save those changes and that update here. One thing to note is, I tried this at like a public internet place like SJSU's, the student union. So like at public restaurants, networks, areas, you might run into some issues connecting your Ngrok server to Slack that allows for interfacing between Slack and Rasa. I didn't have any issues at my home network. I'm currently at my home network, and so just keep that in mind. Okay, so once we have that, we should be able to, So the next thing is verify checkmark, go to Slack where you're interacting with Rasa. So in this case, Slack where we're interacting with Rasa is over here. We just click on this. Messages. And we can say, again, I'm here, I'm visiting colon cancer. What are your queries on colon cancer? So what are your queries on colon cancer, and what are the phases of colon cancer? So what this will do is it'll run a custom actually, no, this is just an utter and just a regular one in the back end. And then what are the signs of colon cancer? So this runs that custom action, which I'll put the data that it finds from Mayo Clinic as it web scrapes it for the signs or the symptoms of colon cancer. And so this is just reassurance that we were able to connect our Rasa app to Slack. Hope this was helpful. There is one more thing I need to check for us, which is the page here. So it's not allowing me to copy it from there. Because I needed to, so if I copy that link, right, I go to credentials over here. Slack channel. Okay, so after verifying this statement multiple times, I believe that our Slack channel, the channel ID is correct. I want to mention here, this is our workspace, the CMPE252 Chatbot Central. And then our channel, aka app, we click on it. So mine is GI Cancers Gallery. Copy that link. This is the link. So earlier when I did this, close to the demo, it had this channel ID. So later on, if you go back and do it, you'll see that it generates a new channel ID. So if we copy and paste this here, what I'll do is where I'm running Rasa server. Yeah, so where I'm running Rasa server, I'll turn off Rasa server for now. And then I will copy this ID over. So this is the latest channel ID. If all goes well, when we test connecting to Rasa from Slack, it should work here too. So loading the model again. Rasa server is up and running. So in that case, this was Ngrok. So the good thing about this Ngrok here, what I'll do is I'll turn it off and then I'll turn it back on. It'll generate a new URL and we'll just get the latest. Okay, so it's back on. If we go to Ngrok inspect where we were at, we'll just re-click that. We'll see that there's a new URL generated. Keep in mind too, channel ID for Slack has been updated because we're going to test that real quick. And then our Ngrok URL has been updated. We're just going to do what we did earlier, update event subscriptions with this new URL. I'm going to change this. Worked. Okay, so this has been updated and that's right here. We verified Ngrok, got the post 200. Rasa run server is running. So next is, let's just verify again. We'll just say again, I'm visiting colon cancer. Awesome. And we can say, what are the phases of cancer? What are colon cancer risk factors? And so again, another custom action was done, web scraping information from Mayo Clinic to get the risk factors of colon cancer. And so we verified if we replace our channel ID with the one that is newly generated from our app on Slack, which is GI Cancer's one, it'll still work. So we were able to verify that and confirm that is where we get the channel ID. And then we also restarted our Ngrok Docker container to get the new generated URL, and we updated Slack's event subscription with it, and then we connected to Rasa from Slack. So hope this was helpful. Thank you for watching.